So let's start with certain situations where LLM performs better than traditional NLP. Okay. Now, let's take the scenario that you are trying to extract certain insights uh, from a vast or huge legal contract. Now, the insights may be related to comparison certain segments, and those segments may be very scattered. Let's assume the legal contract paper has 200 pages, and the particular segments which you want to compare and come to a conclusion, those segments can be scattered around the across the pages. One segment can be the first or 10th page, another two segments can be in 100th or 95th page, and maybe very few lines are related to that particular segments from that particular page. Now these situations in this kind of situations NLP fails miserably because it cannot memorize the previous information. When it will go to the 150th page and it will go through the lines, it may forget the first or fifth pages information. So, and that's where LLM can address the gap actually. Now, how LLM can do? If you notice, LLM can address this gap of NLP by using transformer architecture. For now, it can be a black box for us, but as of now, it's okay. Imagine transformer architecture is just like another ML model or deep learning model. Now, RNN, LSTM, CNN, these are all kind of certain techniques or algorithm. Transformer is another deep learning technique, nothing else. Let's go ahead with this assumption.
Okay.
RNN, to some aspect, RNN can memorize the past data, but if we are talking about second pages data, and we are at 200 page or 150 page, then RNN also may not work, and in many situations it doesn't work. So their transformer architecture can address this kind of gaps. Okay. Now, in in NLP, there are certain ways or certain methods using which NLP can understand that running and runner, these two words are derived from the root word run, and those methods we can call as chunking, how NLP chunks. Now, this chunking method is significantly improved in LLM, and this chunking method is further improved in DeepSeek. That's why we are getting to read or we're getting to hear that DeepSeek is much more cheaper than OpenAI. The way OpenAI chunked the tokens or the words, this chunking method is far more efficient in DeepSeek, and that's why they were able. That's one of the main reasons they were able to build it in much more lesser cost than. But that's a different situation. We will talk about that later. But for now, let's understand the how NLP algorithms used to chunk the letters in LLM. These are different and complex also. Now, here are two business use cases you can go through. One of them is extracting insights or comparing certain situations or certain segments from a legal documents. The another one you can go through. But what I want to, uh, where I want to draw your attention, that these words somehow are related. What are these words? These words are chunking, RNN, transformer architecture, then parsing. We will also know parsing. So unless or until we know what are these techniques, or we have an overall idea then we may not be able to address the gap, or we may not be able to connect NLP with LLM. So we will first go through these concepts, these words. Every words you can consider as a concept. We will learn how chunking can be done. Behind chunking, what are other concepts? How NLP. We first start with NLP, because NLP you can consider as a primer of LLM. How NLP can identify grammatically incorrect sentence. What are the algorithms? Uh, is there any way NLP uh, can relate one particular sentence with the previous sentence? What are the uh, human way, how we understand? If we can do that, definitely we can relate the NLP with that NLP. So we will focus on that. As of now, are we good to go, or you want me to pause or rediscuss some pointers?
This is good. This is good. I think now you mentioned about chunking and parsing.
Hmm.
So we will go back to NLP, so to say, just to understand how NLP used to do chunking and parsing.
And some
And
other stuffs also related to chunking and parsing.
of course. So
Hmm.
NLP does a lot of things,
Hmm.
right?
Hmm.
So and most importantly, uh, NLP still has relevance. I mean,
Right.
everywhere we do not need LLM or SLM architecture or concept.
Right.
NLP still can solve a lot of problems,
Hmm.
right?
Hmm.
So
Hmm.
let us touch upon that also in
Yes.
detail,
Yes. Yes. Yes.
right? Okay,
Absolutely.
yeah, go ahead.
Okay. So let's deal with some ambiguity which can be addressed using NLP and can be better addressed by LLM. So we will take some ambiguities. The first one is this line is taken from a newspaper. The line is saying Virat Kohli was on fire last night. He totally destroyed the other team. Now, where it is said that was on fire. Does that really mean Virat Kohli was running on the fire or was sitting on the fire? No. But somehow NLP can understand that was on fire means Virat Kohli performed really well. Okay, and this understand can be imposed with rule-based structure or some other way. We will see. Another example is now this ambiguity is it's not necessary that it's always will be related to text. This can also be related to an image also. Now, if you see this particular image, if you try to connect left to right, from left to right, it's like a rabbit. But if you try to connect the image from right to left, it's like a duck. So it's a ambiguity in
Yeah,
image.
right.
Then another kind of ambiguity is, suppose I am saying I saw a girl with a telescope. Now, what is the true one? What is true here? Who had the telescope, the girl or me? Is the first picture is true? That means I used a telescope to observe a girl, or the second one, that the girl was having the telescope and I saw the girl along with the telescope. That's another kind of ambiguity. Now, in this scenario, if this sentence is present in some story, some text, then how NLP can understand? NLP will look for the previous sentences or uh, the succeeding sentences, and then NLP will try try to establish a relation, that which or on whom I am focusing on. Have I talked about the girl earlier, or have I talked about the girl after the sentence? If it is so, then it is high chance that I actually trying to observe or trying to see the girl only, not the telescope. And had I mentioned any telescope which I bought, which I am keeping, then it will go through the succeeding and preceding sentences and will look for that and trying to relate past and future sentences with this particular sentence, and that's how it can predict. And obviously LLM can do these things much better. but we will see how it is. But LLM is costly. Again, what you earlier mentioned, the many problems can be addressed in NLP. LLM is not required, and it may help to reduce some cost. Okay, the next kind of ambiguity is, okay, but here if you notice, see, I saw a girl with a bicycle. There is no ambiguity. But I saw a girl with a telescope, there was ambiguity. But I saw a girl with bicycle, I cannot see a girl with a bicycle. That's why there is no ambiguity in this example. Then I saw a bus with a telescope. Here also no ambiguity is present because the bus cannot have a telescope. But this is one situation where the ambiguity is, and if you try to correlate with this ambiguity versus this non-ambiguous sentences, you will find that how difficult it is for a machine to understand the difference between I saw a girl with a bicycle and I saw a girl with a telescope, or I saw a girl with a telescope versus I saw a bus with a telescope. So, but these ambiguities are handled. Now, next come with the next one, which is this one we talked about in the
Right.
on the other day.
Right.
But let's talk about again. So yeah, so schoolboys. Sorry. Yeah, now doing fine. Yeah, schoolboys whom other schoolboys bully. Now this whom is related to these schoolboys. Okay, bully other schoolboys. Again, this bully is related to these schoolboys. Okay, now how the machine will understand that this particular bully is not related to something else, but it's related to this one, this schoolboys. That's another challenge which NLP can handle, and obviously LLM can also. But the particular meaning is there are some schoolboys whom who are bullied by other schoolboys, but those schoolboys who are bullied by other schoolboys, they also bully other schoolboys. Okay, that's the main thing. But here the challenge is machine needs to understand that this particular bully verb is related to the schoolboys. Okay, now let's replace this to make it more complex. Let's replace school with a city in New York State, Buffalo. The boys with buffalo again, which is the animal, and this then again replace the bully, which is a synonym of buffalo. Okay, now this word will look like this: buffalo, buffalo, whom other buffalo, 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 buffalo. Okay. Now the thing is, if this kind of
Yeah.
line is present inside a text, how NLP will understand the inner meaning? How NLP will understand which buffalo is what? Okay, let's assume since this one is a capital, so NLP can understand this one may not be a generic animal or a verb, it must be some name. And from that, let's assume NLP has a huge corpus, huge vocabulary, and from that NLP can search and can understand that Buffalo is a state, Buffalo is a city in New York State. Okay, but what about these two buffalo? How will NLP understand that one buffalo is mapped to an animal and one buffalo is mapped to a synonym of bully? That's the challenge. NLP can address to some extent, and LLM can do better. So here, if we notice that understanding the grammar is one of the key challenges, then the relation between the segment of a sentence, if this one, if this one is the whole sentence, then there are certain segments. One segment is this one segment is this one, another segment is this one, this is the third segment. How one segment inside one sentence are related. Okay, uh, that is another challenge. So relation among the segments of a sentence. Okay? And after that, once this part is done, then how multiple sentences are related, that is another challenge. Okay. So I tried to create certain steps which NLP is already aware of, and that's why NLP can address this kind of problem. Okay, and what are those? What are those steps? NLP can learn, or we actually teach NLP how to break down words into meaningful parts. That means, let's say runner. We talked about this runner and running. Okay. Now this one is is actually denoting a person, okay, who runs, and this one is a continuous part who is running, or it can also be used as a gerund. Now gerund can also be used as a noun. So that information, and the very first step is NLP has to identify that all these two, I mean these two, runner and running, are originated from the word run. This is the first step NLP needs to understand. Then the other part which we talked about, that runner is someone who runs, and running can be also considered as gerund, or present continuous verb, that comes later. But first it has to identify that it's originated uh, with the source, and the source is run. Okay. Then comes the grammatical understanding of NLP. Okay, and that is related to the syntax. We will see how syntax is, how what is syntax actually. Okay, and how NLP can identify that which sentence is grammatically correct and which is not. We will also understand that. Then the meaning, the relation between the relation among the segments of in a sentence, that comes under the semantics. Okay. uh, now, then comes pragmatic. Now pragmatic means, if you are saying someone, let's say you are saying to a junior of yours, and what time is it, and you are in a meeting room, maybe you are trying to convey that you are so late to join the meeting. That was you are trying to convey, but the literal meaning of what time it is 11:42 a.m. But that's not the case you wanted to convey. Another sentence can be, if you say me, if you tell me that, can you pass the bottle? That means you actually are wanting the water bottle, right? Now the literal meaning, according to the literal understanding, I can say, yes, I can pass the bottle, and then I stop. That should not be the case. I actually passed with the bottle, right? So this kind of understanding should have in a linguistic application, and that's where pragmatic comes. Okay. And then maintaining the coherence, this is another one which is really well addressed by LLM. I was talking about that segments can be scattered across the pages. Some segments can present inside second or fifth page, some segment can be present inside 100th or 150th page. So the coherence we should maintain, or the application should maintain. So that comes under the discourse part. We will now each of these component, the morphology. Okay, where it is? I can't find my mouse. Yeah, morphology, syntax, semantic, pragmatic, discourse. These we will discuss today, and you will see that if you use these words in your prompt, like pragmatic, discourse, if you use this kind of words in your prompt also get giving you a better result. Okay, because those LLMs are also built on this concept, so they really use what pragmatic means, what discourse means. So you can use these words in your prompt also. But first, let's understand, or let's let's have a definition what each of these concepts mean. Okay, I'll pause for a minute and uh, I would like to hear from. Are we okay? Anything you want to?
Yeah, yeah. This is perfect. It is in fact making more sense because, as you rightly said, each of the prompts or each of the platforms like ChatGPT,
Mhm.
the more you use it in the right way meaning with the context,
Mhm.
with these kind of keywords, like
Mhm.
a discourse, like a pragmatic, they are able to relate,
Mhm.
which makes it even more important to understand NLP well,
Mhm.
then get on to the deeper subject of LLM,
Right.
and then start doing prompt engineering. Prompt engineering is not Googling.
Is very upper layer. I mean, it is very upper layer of the whole NLP LLM
It
concepts.
is becoming
Yeah,
very, very apparent
yeah,
that it is not equivalent to Googling, but
absolutely.
that is how things are getting portrayed. Anyone can become a vibe coder. I really disagree. Anyone cannot become a vibe coder if you do not have the right background. I'm not saying you have to be a programmer,
Right.
but you need to know the context, the basics really well in order to structure a good prompt.
I agree. Absolutely.
Yes,
Absolutely.
very clear. Go ahead.
Okay. Okay. We will start with promptology. Sorry. We will, my bad. We will start with morphology. Okay. So yeah. So what does it mean? If you understand morphology, you can decode the structure of words and the relationship among words. Now, please pay attention. I am saying relationship among words. I am not saying relationship among sentences. I am not saying relationship among the segments of sentences. No, morphology deals with the words and the relationship among words. Okay. Now, there is another terminology, that term which is very important, which is morpheme. Now, what does it mean? Uh, this is okay. For example, which is already given here, that taking and courses. If we consider these two words, their morphemes are take and course. Okay, and course. So morpheme is, you can consider the building block or the atomic atom. You cannot break it further. Okay. Uh, though atom can be broken, let's keep aside that particular discussion for later. But morpheme is the
Okay.
component which you
So
cannot. Yeah, yeah.
quick clarification. If I just want to clarify my
Mhm,
understanding.
mhm, mhm.
Take and course are the base words or the atomic structure, right?
Yes, yes, yes.
Which means, say for example, I take a word called decoration.
Mm, mm.
So decorate, decoration. So which one here is the base word or which one
Very,
is the
very
morpheme?
good example or very good word you chose. Why is it so? Why I'm saying so? There are certain techniques using which you can identify or extract morpheme from a
Ah,
word,
ah,
from a
right.
word. Now, one using one for one technique, the morpheme can be decor.
Yes,
For another
yes,
technique, the morpheme can be decorate.
correct.
Now, what is the difference? This morpheme is not from a knowledge base or dictionary, but
Mhm.
this morpheme is from a knowledge base, or you can say from a dictionary. Now,
Okay, so
this
how did you arrive at that this is not from a knowledge base and this is from a knowledge base? How do we arrive at that?
okay. So when we are trying to build NLP NLP kind of application, we always
Hmm.
deal with the thesaurus of vocabulary. Now,
Correct,
in
correct.
most of the cases, we keep those words which are being extracted from a dictionary. In most of the cases, but there are cases in terms of chunking, we do not do that. Now, the if now there are mostly two ways using which you can extract morphemes: stemming and lemmatization.
Hmm.
If you use stemming, there may be some morphemes which are outside from a knowledge base or a dictionary kind of thing, which may not give you any stable meaning. You cannot find those words in a dictionary. But lemmatization
Hmm.
always try to extract morphemes in such a way which is from a knowledge base.
Oh, okay. Understood. Just say the stemming part again. So, stemming and lemmatization,
Mhm.
uh, these are pre-processing steps to be performed when I'm starting to work on any NLP project.
Yeah, there are certain packages what to be kind of thing.
But these are like must-haves. The way it is, if I have to draw an analogy,
Mm, mm.
it is as good as saying that if you do not do the data exploration well, you cannot go and start doing any statistical modeling or any
Right,
mathematical
right,
modeling.
right,
You first do a data exploration. So
right.
this is the mining part of it,
Yes,
analogically.
yes, yes,
Oh, understood. Understood.
yes. Okay, now let's deal with syntax. Now one can spend hours and hours to understand morphology. These are the high level understanding, so that we can jump on the other technical aspects. Okay, these discussions or these concepts are more related to the uh, linguistic related subjects. So, but still we need overall understanding to for going ahead. Okay, so we will discuss the syntax now. The syntax, you can further break syntax with three components: parts of speech tagging or POS tagging, chunking, and parsing. Okay. Uh, Now here we will understand how NLP can identify a grammatically incorrect sentence, and this is most of this logic is rule based, and we will see how. Okay. Okay. Let's first discuss the POS tagging. Now at the here you can see certain uh, you know you can see a table. We will discuss that later. But okay, now parts of speech, the way in English grammar we understood parts of speech, it was noun, pronoun, verb, adverb, preposition, conjunction, interjection, article, and so on. But here it is not exact. Okay, mostly we and there are two methods, very popular methods to identify or to denote to tag for POS tagging. One is this pen tree bank tag set, and another is this C7. Okay. We will mostly deal with in this session. We'll mostly deal with pen tree bank tag set. Okay, there are 45 tags altogether. And here, if you notice, some tags are mentioned here. S is the whole sentence. NP is the noun phrase. DP is the verb phrase. So any sentence you can divide with this noun phrase and verb phrase. It's like subject and predicate form. So let's deal with this one, which is he ate an apple. Now he actually the noun phrase, though it's not noun, it's a pronoun. But still, when we will break it, we will consider it as a noun phrase, and this whole part will go including the full stop. This whole part will go into the noun phrase, and then further noun phrase can be broken into several component: verb phrase, personal pronoun, verb. We'll see gradually. We'll see. But here, let's understand that POS tagging can also be ambiguous. If you consider this first one, he went to the park.
One quick question.
Yes, yes.
You so pain, Prebank, Taxet, and C7, are these like a established bank from where you are trying to take help from the on the tags?
Yes. So
Uh,
how?
okay,
So it's a universally acceptable thing. So like
okay.
let's take it this way. So by F universally we denote force. By X universally we
Hmm.
denote variable. So kind of that. But there are
Oh, okay.
other techniques or other algorithms also. But these two are very popular: pain tree bank taxon and uh, Caesar.
Understood. Okay.
Yeah. Yeah. So POS disambiguation is there. Like here, the park is actually being considered as the noun, and the tag you can see here, right? But here they went to park the car. Here the park is being considered as a verb. So POS tagging, ambiguity in POS tagging can be there. Moving on, let's discuss the chunking. Let's see how it is. So chunking and parsing is very much related. So let me write here. So I'm going to write the sentence. The sentence is, he went to the Indian Museum. So let's start here, S. And S can further be divided with two leaf nodes, NP, noun phrase, and verb phrase. S is the whole sentence, where the whole sentence will be there. He went to the Indian, and so on. I'm not writing the whole sentence. Now here, he will become as noun phrase, though he is not a noun. Inside noun phrase, we can tag it as a pronoun. The verb phrase will be the rest of the sentences. Went to the, and then the rest of the sentences. Now, this one will be tagged as verb. This one will be tagged as preposition. This one, we will, in this tagging methodology, we do not say article. We will say determiner. Okay, DT. The tag is DT here. If I go above, yeah, determiner. So these are actually meaning we are talking about article. And okay, now there are rules which are included in certain packages. That, and what kind of rule it can be? The rules are that this is a preposition, right? And this is a verb. One rule can be, if you do not find preposition after a verb, there are high chances that it would be grammatically incorrect. Or if you do not find any noun phrase before a verb, high chance that it will be grammatically incorrect. And if you try to recall, I can still see this, that Grammarly is automatically integrated in my Chrome. Now when inside Chrome, I use a Google Doc and I am writing some lines. For example, let's say, for example, will be back in a minute. And it actually underlines this will part. And when I click on the suggestion, it gives me suggestion I. And the same logic is happening here. At the back of Grammarly, someone wrote that before noun phrase, before a verb phrase or before a verb, if you do not find any noun phrase, there are high chances that someone is doing some grammatical error. So give suggestions in this way. And so, yeah. So kind of all these tags. So there are, if we go up and we see that in the first method there are 45 tags. In the second method there are 146 tags. In Paint Tree Bank tag set, this arrangement of tags are already written by the people, and according to that, so first NLP takes the sentence, it tries to identify or it tries to tag each of these words with those tags, and then it will apply those rule engine, that if this particular tag after another particular tag or before, if this is so, there are some particular error in the grammar. But even before tagging, the morphing part should be done. Why I am saying so? Let's take the example of runner and running.
So by tagging, just to clarify my understanding, when I say 45 tags, so tag is this S for sentence, NP for noun phrase, and all this.
Yeah, I have taken a few only. Yes.
And then there are so 45 and 146. Majorly, this is kind of the universe.
Yes.
Okay, understood. Yeah, right.
So if NLP wants to tag it, let's say NLP wants to tag running. Now this running can be a gerund, or it's kind of it can come under the verb phrase. even before tagging it, it's really important the origin of this word. So morpheme, identifying the morpheme comes first even before tagging. Okay. Okay, moving ahead, let's understand the chunking part. Chunking part we already discussed that how it is being divided into these segments. Let's understand. Okay, here if you notice one correct sentence and another incorrect sentence. Let's try to chunk it. Okay. So he eats a mango and he mango eats a. Okay. Let's first chunk he eats a mango. So noun phrase, then verb phrase. Inside noun phrase, he will come, but he is actually a pronoun, so it will be further be tagged as a pronoun. Verb phrase is eats a mango. Now it will actually be a verb, VBZ. A will be the determiner, DT, and mango will be again noun phrase because mango actually ultimately a noun. Okay, so that means if you notice from sentence, from S, it is becoming NP and VP. This one and this one, right? VP further is broken into VBZ, DT, and
BT and NP.
NP.
Yes.
And NP further can be broken into pronoun. The tag of the pronoun I don't remember. I have to work and check.
Not a problem, but yeah, conceptually this is the breakdown basically.
Yes. And now let's try to break down this one. Now here also he, that means this NP to pronoun will be there. Mango eats a, that means NP comes first. NP comes first, and this DT will go last, and this, so the arrangement will be NP DT, sorry, NP
VBZ and VBZ and DT.
And DT. Now here inside another branch pronoun is also present. This he is also present. Now there are certain rules that after a noun phrase is another noun phrase, there are high chances that the user is doing some grammatical error.
Some grammatical error is there.
So this is the rule is already written by someone, by some people, by some team, and that was what we got to see in Grammarly or this kind of application. Okay, so this is the syntax part of, and then we will move to the semantic part. And here you can see the further breakdown. That just what we discussed here. The same you can see here. He eats a mango. This is the right one. But if you try to understand he eats mango, it will be jumbled up, and the wrong arrangement will be there. Moving down, yeah. So the same example is taken here. I saw a girl with a telescope. Now syntactic, try to enjoy the syntactic ambiguity. How is it? So this is the whole sentence. Okay, I saw a girl with a telescope. Okay. Now if I try to approach bottom up, I becomes noun phrase. You can see. Now further inside noun phrase, always I is becoming pronoun. So the tag for the pronoun is PRP. The rest of the sentence, which means the rest of the sentence, how can I change the color? Is there any way to change the color of the pen?
There should be. When you select the pen, there should be a color also. Just click on the pen. Yeah, so again, come down. There are two, one red dot, one green dot. Can you click there?
Okay, these are the width.
Yes. Oh, achha.
But anyway,
it works. Yes, purpose is solved.
Yeah. So I is going to the noun phrase, and further noun phrase is broken into PRP or pronoun. Rest of the part, saw a girl with a telescope. This part is going to verb phrase, and the same is true for here also. Saw a girl with a telescope. Now saw is actually a VVZ or verb. What is the noun phrase? A girl. Saw whom? A girl. Noun phrase is further broken into determiner and noun.
Mm.
Now notice this NN is not noun phrase, it's the noun itself. Okay, so
Correct.
noun phrase is further broken into determiner and noun.
Mm.
And here the same thing happened. The twist is in this scenario. Okay. My bad, sorry, I mistakenly clicked it. Okay. So,
No problem.
So this is the main confusing part where with the telescope we are considering. Now let's understand it. This verb phrase is further broken into verb, noun phrase and PP. What was the PP? Let me go up.
PP was there. PP is prepositional phrase. Prepositional phrase.
So PP is the prepositional phrase which is further broken into preposition in and noun phrase. But here this PP is originated from the verb phrase itself. This PP is originated from the verb phrase itself. But if you notice, here this PP is originated from the noun phrase. Compare this noun phrase with this noun phrase. This noun phrase has 2 child nodes and this noun phrase has 3 child nodes. That means the structure is different and here, can you tell me which one is related to? If I talk about that, I saw a girl. The girl has a telescope. If I want to mean this, which structure is related to the sentence? I saw.
Okay. The girl had a telescope.
The girl had a telescope. Which structure is related to that one? Because the girl had a telescope.
The second one.
Yes, and that's why the whole part is coming under noun phrase.
Yes.
But
here the prepositional phrase is becoming a child node of the noun phrase, and hence the meaning, the breakdown of the sentence. I saw a girl and the girl had a telescope. That is more suited to the second structure.
Yes, and that's what you can check. You are absolutely right, because the picture itself is telling so. For this particular picture, where the girl itself had the telescope, is related to this structure. But if I have the telescope and I am observing the girl, then this structure is the right.
Correct.
And this is the ambiguity. One NLP model can break down. I saw a girl with a telescope with this POS tagging. Another can break down with this POS tagging. Then the meaning will be different. There will be certain errors, and it depends which one is correct or wrong.
Okay, so in that case, are we saying that depending upon the choice of NLP model, it might predict the right instance or the wrong instance? That is one. And second, if it is wrong, there is no possibility to go for a self or auto correction. By that I mean, when it has actually scanned the entire data, of course there is a meaning, there is a context of that entire data, right? It could be a paragraph or it could be multiple paragraphs,
right.
And then it learns from that data and parses or basically breaks down in the right syntactical way. Is there not a possibility?
Yes, actually that should happen actually.
I mean, that's the ideal situation.
Yes, that's the ideal situation. Now, I mean, if the data is not, so suppose this particular sentence is present inside a story or some news article, and the relevant sentences is not correctly structured, or then your NLP model cannot help. It will run the wrong way. Okay, so that's how it is. And NLP, while NLP can be the solution in many of the cases, NLP has the drawback that NLP is trained much lesser amount of data compared to LLM. The LLM, this kind of situation can easily be addressed because the training data is huge and huge. You cannot even imagine. But NLP is not the case. But yeah, surely in some cases it may still work, and it's working actually.
So here the concept of token and tokenization doesn't exist in NLP, right?
No, definitely exists. We'll come.
Oh, okay.
We'll come to that gradually. So the tokenization part is very relevant to the morphology, the morphemes.
Correct. I was kind of finding it analogous, and hence I asked that maybe morphology as a concept has some limitation against tokenization. But it exists. Okay, we'll wait.
And there are methods to do.
Understood. Okay, we'll see.
Yes. Okay. Now here, let's talk about the semantics. Now, it's said that this is the glue that connect language to the real world. Okay. And semantics is related to the segment of the sentence, how they are related, what actually they are trying to mean. But semantic has the limitation. If your application is semantically sound or semantically capable, still it may not identify this particular phrase or this particular sentence, which is pass me the bottle, or could you please pass me the bottle. This particular sentence cannot be identified as semantically sound, or may not be identified as semantically sound application. For that, your application should be pragmatically sound or pragmatically capable. So, why I am saying so? Because to convey the limitations of the semantics. Now, there are certain types of semantics: decomposition, ontological, and distributional. Now, decomposition is very relevant to the decompositional prompting technique which we learned. Breaking down a complex problem into smaller. Now, here we do not break down the complex problem, but rather we break down the concept of the word. How is it so? Let's say the one kind of word is bachelor, and what are the features related to the bachelor? Unmarried, at least 20 years aged, or 25 years of age person should be. The other features are male. Okay, high chances that when I am saying someone bachelor, he or she should be independent, right? So these are the features which a decompositional semantically capable NLP application can identify from a particular word. Okay, and that's what is given in here also. Decompositional semantic. Here we took 4 words: boy, girl, woman, and men. And certain features are tagged as plus, certain features are tagged as negative, because man is not a female, boy is not a female and adult, but women are both human, female, and adult. And there are many other features also which are not listed, but for an example perspective, this is what decomposition semantics means. Next, we will discuss ontological semantic. Ontological semantic is very much related to the mind map, you can say, or to some extent ear diagram, not exact ear diagram, where there will be there will be vertex and edges. So vertex will be edges is actually denoting the relation. Okay, so let's take this example. Let's take tractor. Tractor is one vertex, then self-propelled vehicle is another vertex. But how it is being connected with this edge, and this edge is actually denoting the relation. And this one kind of mind map, this kind of mind map or this kind of relation exists. You can search for WordNet, where you can find the vast relation, and that's how NLP establish the relation actually. Now, if you try to figure it out, that how car is related to wheeled vehicle. How car is denoted. To relate car with a wheeled vehicle, NLP has to go through this path. First it will go here, then it will go here, then it will go here. Okay. So in this way, again, the accelerator can also be related to wheeled vehicle. How it will be related? Using these arrows. Let me remove other so that it's easier to follow. So related to this one, tractor, accelerator. From here, this edge can be reached. This vertex can be reached. This vertex can be reached. This vertex can be reached. And there is some relation between wheeled vehicle and accelerator. And in a sentence, if NLP finds or any NLP application finds that wheeled vehicle and accelerator is present, some correlation score will be calculated and it will be stored at the back. Okay. But if you can definitely have the hunch that the farther the vertices are, the weak the relationship will be. Okay. But that's also, I am guessing, I am not 100% sure, I have to verify, but that should be the situation, that should be the case.
Okay.
Yeah. So next is the distributional semantic. It's all about how the words are distributed in a particular sentence, and if you notice this, it's actually kind of a correlation matrix, or here it is denoted as co-occurrence matrix. If you notice that dog, walk, after dog, walk happens 5 times in the vocabulary. Okay, that's why you are getting to see 5. Dog owner 5 times, dog run 2 times. But if you notice, actually dog runs should be there, not dog run. But here it is the NLP application considered the morpheme run only. Okay. Then again, dog owner, dog paid. So after dog, leash occurs 3 times in the whole corpora. Dog walk happens 5 times. Dog bark happened twice. In this way, you can infer this. Okay. Lion leash doesn't happen. Lion walk, lion run. So that's how you can infer. And if you notice that if someone asks you that, and let's consider that I am an NLP application and I have to predict the next word after dog. Which one I should predict? 3, 5, 2, 5, 3, or 2.
How did you arrive at these I mean the matrix numbers? Is it random? Is it arbitrary? How is it?
Yeah. So actually, what happens? Let's assume you have a collection of 5 sentences. Okay.
Okay.
And there you can actually this is not the full structure. That's why the confusion is.
Oh, okay.
Here, all the words should be listed, row-wise and column-wise.
The entire corpus.
The entire corpus, exactly.
Oh,
that's actually should be the square matrix. But yeah, but that's not the case because there is scarcity of space. So, and then we are comparing. And according to this particular table, I can see after dog, walk is present 5 times, owner is present 5 times. The rest of the words are less than 5. So I will either predict walk or owner.
Oh, this is simple frequency of that.
As of now, it is so. So yeah. So and the same thing is for the other words also. But the the way, or not the way, the convention is reading the table row wise. That means we will not read after leash which one is appearing. After leash, dog appeared 3 times. After leash, cat appeared 3 times. This is the wrong way to read the table. Convention it is.
Okay.
Conventionally, we should read row wise. So we will read after dog, which word appears. Owner appears 5 times. After light, nothing appears. All are zeros. Because if you try to recall or try to have an overview, light is not very much related with these words which are present as the column name. bark is related to owner or pet. Okay. Does that mean bark is not related to dog? Very much related to dog, but according to the table, the data is not present because this is not the exhaustive table. Okay. But the convention is reading the table or inferring the table row wise, not the column wise. We should not read in this way that after owner, bark present 2 times. No. After bark, owner is present 2 times. That's what the sequence you should follow. Next is pragmatic. Okay. Now let's address. I already discussed those. The pragmatic ability can help NLP application to identify this kind of sentences. Can you pass the water bottle? The literal meaning is, are you able to pass the water bottle? The response can be yes. This is the literal meaning. So actually, NLP should understand this, that by this, someone wants to convey this. The pragmatic meaning. Oh, sorry, my bad.
Pragmatic is without any courtesy or gesture, the straight answer of pass me the water bottle, open the door, kind of stuff.
Yes. So this should be the literal meaning that NLP should not understand.
Literal meaning is pass me the water bottle.
So okay. Are you able to pass the water bottle? That's the literal meaning. But NLP should identify the pragmatic meaning also. Pass me the water bottle. Okay. The same thing is here. Do you know what time it is? The literal meaning is, are you aware of the current time? The answer should be yes or no. But that's not what we are asked. We are asked, why are you coming so late?
Correct.
So that pragmatic ability NLP can achieve. Okay. And obviously LLM also. So the discourse. Now the discourse is now here I will go back to that buffalo example. Let's go through this sentence first. Mother said, John, go to school. It is open today. Now NLP should understand what is open today.
It is the school.
Yes.
NLP should be able to understand. Yes.
Are you planning to bunk? You means whom? Bunk what? Bunk what?
Correct.
Father will be very angry. Okay.
Whose father?
And why also?
Why exactly? Why will father be angry?
Yes, exactly. So this kind of things NLP should understand. And again, if we try to recall this concept, try to recall the sentence, high school boys whom other high school boys bully other high school boys. The last bully is related to which high school boys?
Correct.
Mid segment high school boys or the initial high school boys? So that was another part. So this comes under the discourse technique. So that's the overall linguistic approach to I would say decode a particular sentence or some sentences, or linguistic approach, how NLP approaches the text. Okay. And under the hood, all the mathematical application happens. Now we will start going there. So before even understanding large language model, I would like to go with language model. Then we will go with large part. Here in this language model, we will. Okay, now comes this part, language model, and it's mostly covers the NLP section. You can.
So in the discourse, going back to the discourse, so there are a lot of question marks that we are not clear in discourse, and these are all the different types of problems that we are going to now solve using language model.
So you can address morphemes, you can extract morphemes efficiently using language model. You can understand if a sentence is grammatically correct or not. That means the semantic, that means the syntactic, then the semantics understanding. All these layers can be addressed. I would say layers. And if you notice that first we discussed the very simple layer, extracting the morphemes. Then we go back. Then we discuss the grammar. After that, a bit complex one, which is the semantic. Then a more complex, the pragmatic, and this is the most complex one, the discourse part. And this is the actually layer. These layers are followed by the NLP applications. Okay, and any NLP applications, most of the NLP application I would say is trained using this layer, and these layers are arranged in a increasing difficulty level. Okay, and now we will understand the language model using which we can address these layers and using which we can understand how the layers are actually being performed under the hood. And mostly the language model, any language model can be divided into two sections. One is statistical and another is neural language model. Inside neural, you can have fixed window, RNN, CNN, and statistical language model, you can have n-gram and exponential. Now we will discuss with n-gram a couple of sessions, or maybe 1 or 2 sessions we will spend on the basics of deep learning, then we will jump here. But sure, we will first discuss the n-gram and exponential. Today we will start with the n-gram. So let's do that. So I was actually prepared for this layers, discourse, semantic, these things, and the n-gram today. But
yeah, we should not proceed beyond that. Even n-gram, I think we can wait if you want. We can do it in the next session also. But you can give a context, as in context setting for n-gram, and then we will revise and we will get on to the other statistical language.
You can also see earlier you were talking about printing some pages, right? So I have uploaded a couple of books. One of the books are from Stanford. They are using their speech and recognition language models, speech recognition course. So from there you can read the 3rd chapter. This is all about n-gram.
Achha, okay.
I actually took from that book also to material. So I will going to discuss. You will see lot of similarities, lot of similar content which we will discuss here. Almost same. Okay. So
understood. Any video that you would recommend or no?
The videos are, I can refer. Couple of videos, short videos, 7 to 10 minutes, something you can refer. But let's start with some concepts so that we can continue later with this one, right?
Okay, wait. You have mailed me the G drive. What is the name of the G drive?
I have shared it. So it won't in your mail, right. The G drive is large language model session something movie. Okay, so you should search with BM Shatodru. It's the drive is shared with another G drive because the Gmeet is shared from another Gmail and the drive is shared from another Gmail because I did not have space much, so I had to create another account for that.
Understood. So not a problem. If you want, we can have another account just to share and save all those things. In that case, we will have a lot of space. And I have Google paid version, so of course there is a limitation. I don't have a 2 GB thing, but if needed for 1 year, I can still subscribe and then I will downgrade. Not a problem. Okay, hold on. Let me quickly share my screen. Let me just see where is it. Okay. Let me know if you are able to see my screen. Now in Shatodru curriculum. So curriculum is also in that drive?
No, I will upload. Curriculum is curriculum 1. So go back to the mail. Let me see.
Updated invitation, LLM model.
Search with BM Shatodru in the search box.
Okay, BM Shatodru. Folder.
Yes.
Okay, fantastic.
Now there are 2 session materials, another one reference materials. Click in the reference materials. No, session materials is khali, it's empty. Go with the reference. You should have this ED3 book.
ED3 book. Okay.
So from this book you can print the 3rd chapter. There are 1st and 2nd chapters also. 2nd chapter will be discussed maybe next to next sessions, but now I am covering going to cover the third.
So you are asking me to take the printout for annotating linguistic
No,
structure.
this is the summary of the content. This is not a
Oh, okay.
Scroll
Acha, N-gram language model. Yes.
yes, this one.
Pages 32 to 55. Acha. Okay. Understood. Okay. This is a good book. Yeah, it has everything covered.
Everything covered. Even RAG is there.
Oh, even RAG is there. Okay.
They started with the very basics, which is regular expression.
Ah.
Okay. But I'm not discussing here. I will.
ELIZA and all those things.
Yeah,
Understood.
I have not planned to even discuss the regular expression, but definitely I will cover second chapter. But let's focus on the third chapter. Let's at least start discussing it, and then you can,
Sure. Fair enough. Okay. Cool. Understood.
So N-gram is, so if I want to talk about N-gram, it depends on the very basic conditional probability, and for the sake of completeness, let me just write this once. So if you talk about two events A and B, you can write it this way: probability of A given B into probability of B, or even you can write probability of B given A into probability of sorry, A should be.
It should be A.
Yes. Yeah. So that's the all concept we need. On this concept, we have the N-gram established. Now let's start discussing.
Oh, it's only union, not the sorry. It's only the intersection, not the union.
No, only the intersection will do the work.
Oh, achha.
So actually, in my stats days, in schools or in colleges, we learned it this way. So probability of A given B is equal to probability of A comma B. Then
B. Correct. NG Das.
NG Das. Then
I never followed NG Das, by the way. I used to follow a book called Giri
Banerjee, exactly. I followed that too. So I had stat in my 12th in my HS. So NG Das were mostly recommended for the commerce guys. I saw that.
Correct. And then Gungupta Dasgupta was also good.
Yeah, Gungupta Dasgupta I followed for honors papers.
Correct.
And then Purimal Banerjee was there.
Gupta Kapoor was there.
Yes, one is there. Yes, Gupta Kapoor is there. Exactly, Gupta Kapoor is there.
The one book is enough till masters, no problem.
Gupta Kapoor is actually enough. Yes, it's a lot of depth.
More than sufficient. You don't need multiple books.
And then statistical approach to linear regression is very different than the ML approach. ML approach starts with the linear algebra, those
very different. Even econometric approach towards linear regression is very different. Very different. Yes.
And that's where the tussle, and it still exists inside me. That way.
So linear regression is probably the best algorithm I have ever studied in my life till now. I know very few. But I think with linear regression, I can solve at least 60-70% of the problems. The world is not that non-linear, so to say.
Okay.
At least parametric estimation, from parametric estimation point of view, because you can bring in all the transformations and then put it in a linear format. Who is stopping him?
Right. So I saw OLS method. I started learning linear regression with OLS method, ordinary least square, and then I started. Then I came across the maximum likelihood estimator.
Correct.
Which also can help you to solve linear regression. So
of course, MLE can help you solve linear regression. Actually, yes.
Anyway, so we are drifting.
All right. Yeah. No. This conversation will never end. Yes.
So
go ahead.
Okay. Now, let's discuss this a bit more.
Yeah, we have. Let's talk for another probably not more than 10 minutes because I don't want to overburden myself or you as well.
Yeah.
Right. Okay.
So this particular thing can also be written this way: probability of C into probability of A intersection B given C, right? And if we talk about, if I go further, so let's talk about or we can think it this way also. There is some probability of, let's take it this way, probability of A given B into probability of C, probability of A intersection B into probability of C given A intersection
B intersection B.
Now further it can be broken in this way. So probability of B given A into probability of A into probability of C given this. So this and it we can also generalize for this one, A0 intersection A1 intersection intersection. It can be generalized. So this concept will be required.
Right.
But now let's jump to the one quick math, and that should be the ideal to conclude today's session. Let's discuss this. So I am going to write three sentences. Okay. Three will work. So let's say sentence 1, which is the cat sat on the mat. Sentence 2 is a quick brown fox. Quick brown fox jumps over the lazy dog. Now sentence 3 is she sells
seashells.
Yes. By
the seashore.
Yes.
Amazing.
These are 3 sentences, and now we are going to talk about we are going to predict actually that what should be the probability of occurrence this sentence, the lazy cat sells seashells. Now you can consider all these as a separate. This is A, let's say A1, this is A2, this is A3, and these are all intersection. You can imagine in this way, right?
Oh, okay.
Now we will we needed this this concept, and if I try to write this particular concept, then how can I write so? First, let's start writing. Okay, so you can think it this way, that shells will be predicted given the lazy
cat
sells
C. Right. Achha, okay. All the elements basically.
The lazy cat up to C.
Up to C.
This
Yes.
is actually nothing but if this is A1, A2, A3, A4.
You are just breaking it up.
Yes.
This is the conditional probability.
A6, yes. A6 given A1, A2, A3, A4, A5.
Correct.
Okay. And this can further be broken. How? This can be broken. Probability of C given the
lazy cat
sells into the lazy cat sells. And then further the lazy cat sells further be broken. Probability of sales into the lazy cat.
The lazy cat multiplied by the probability of the lazy cat.
And then probability of the lazy cat can further be broken.
So that way it will iteratively keep on breaking down till it actually predicts.
Yes.
what you want to predict.
Yes. So all of these things you have individually be ready with this probability.
Right.
You have to be individually be ready with this probability, and then we multiply, and then we will get the probability of these words. Then we will find what is the probability of these words being together in this pattern. So, I mean, if someone says the sails, sea, cat, this is another pattern. But in this particular pattern, what is the probability that this particular pattern of these words exist? That we will get. Now the challenge is the Markov assumption here. Let me conclude with that. Okay. So when we are saying this one, the probability of shells, when you will find the lazy cat sells C. Okay, that means we are assuming after the lazy is there, after the lazy cat is there, after the lazy cat sells is there, after the lazy cat sells C is there. Then in this condition find the probability of shells. But here, if you notice, these are our corpus, right? No sentence is saying this, that the lazy cat sells C. No sentence is present there. That means this particular probability will be 0.
Yes.
That means
as a sentence it does not exist.
Yeah.
It exists in different ways in the entire corpus.
Yeah. Now this probability is actually trying to think us that how shells, the word shells, depends on this particular arrangement. Markov assumption says that we can decrease it. How? We can decrease it to this way, that if this particular thing does not exist, we can say that let's calculate the probability of the word shells when only the remove the lazy cat sells C. Okay, and further it can be broken. Let's remove this. Only probability of shells, only cat sells C. And in fact, this can also be broken into this. So only probability of shells given C. Okay.
So it's the Markov deduction basically.
Yes. So if we reach this line, we can say this is the bigram.
Oh, okay.
Okay. But if someone is only trying to predict probability of shells, this is the
unigram.
Exactly. Now, if you try to find that after C, where shells is present, so actually, if we let's talk about this one. So it will actually what? Count of C and then shells by count of C. This will be the probability for this particular thing. Now, if you go back here, you will let's go back here and let's see where C one occurrence is here. After C, there is only one time where you can see after C shells present. Right. So count of C and shells is actually 1. But what is count of C? Let's count that also. C is there. Any C is there? No.
2.
So if that is the thing, then this will be 1 by 2. That means the probability that after C shells will be present is 50%.
That's a C. Correct.
Okay.
It's a 50% probability.
Yeah. So and that's the Markov assumption. Okay. And then you can go with unigram, bigram, trigram. Okay. And then
so all even till n-gram, it is actually using the Markov assumption under the hood, right?
Yeah, in this n-gram language model only. But there are high chances. There are way too smooth also. Why I am saying so? Because there are chances that probability of you have to calculate probability of shells after the word C. But in your whole corpus, C shells is not even present. Then the probability will be 0. But that should not be the case. That means in your training data, the data is not present, but your test data, the data is present.
Understood.
Then what you will do? Then this kind of situation you can address using Laplace smoothing.
Ah, ah, great. Now you are getting into math. Okay,
Yeah, slowly.
very good.
Uh,
Uh,
and then this Laplace
but
method is
I mean, Python or any programming language, they have the libraries
like
where
this.
your the mathematics is taken care of.
Yes, they have the libraries.
Hmm.
And if we, I mean, if someone has the scope that they can create those class and functions by
Hmm.
hand using core Python, there is nothing like
Ah,
that. The package is also there under the hood. How the package is constructed is clear to him or her, and also the math will be clear.
then you can develop a scikit-learn too.
Exactly, like learn to, and that's what I was planning to do for LLM to
We
build
will do
the,
it.
yeah, to
We
build
will
the
do it.
GPT-2 from scratch.
Oh, fantastic! That is our pet project.
Okay.
That is our pet project. Yes.
I mean,
Karwa AI के बाद we will do this.
this has already done by Sebastian Rastak, and earlier you had Visuala.
Rashta has done it.
Yeah.
Correct. So that is they are researchers, right? They don't need to run after clients.
Okay.
That is not their job. So they have all the world's time to break their head there. We will do it.
Yeah. Yeah, and
Sure.
then you can go with Laplace smoothing. Laplace smoothing is very, I mean, not very complicated. It just add, let's suppose 1 by 2, and if it is 0, then it adds 1 extra, and then the whole vocabulary thing, the whole corpus we adjust. Maybe it's not much clear now, but you will get to, if you know,
We will gradually get there.
yeah.
We'll
In the
gradually get
material
there.
itself, it's
We
there,
will.
we can discuss. Yeah.
I think the way we should now do is now that conceptually it is I am able to make sense. I am able to tie the connect the dots. Now we can take a small sample data set, try to see how to execute it in Python.
Okay, let me finish the statistical
So I
language.
leave it up to you. Of
Yeah,
course, of
yeah.
course. So I completely leave it up to you how you want to do it. But yes, then it is like by hand.
Okay.
I know how it is actually coming out.
Right.
Correct. Let us clear the concept. Fantastic. Great. So
Yeah,
this is good.
we
This
can
is very
end
interesting.
here today, but ideally tried, I mean, the purpose was to cover the whole
Hmm.
in-drum part along with the previously discussed topics, but I did not think that it would take that much time.
No, that is it is absolutely understandable. I mean, it will be we will go like this only. So we will go -2,
Mhm.
come to 0, again +3. Again we will go -2, come to +3. Like that we will proceed.
Yes.
It will be good. Otherwise, we are not in a hurry to learn everything in one shot. It is not going to serve the purpose.
Great.